Hello everyone, hope you are doing great. So in this video I will talk about thread and virtual threads and what are the key differences between those. So as we know, thread and virtual thread both are used in Java applications to manage concurrency, but they differ in the way how they are managed and scheduled. So I will quickly jump into the key differences of both the points. So first one is heavyweight. So thread is heavyweight because they are managed by operating system. And every new thread creation requires a system call, which can be expensive, as context switching between threads can be costly in terms of performance. And we generally use thread pools to manage resources efficiently. And second point is limited scalability. So these threads have a higher memory footprints, so make them less scalable. And excessive thread creations can exhaust system resources and further system performance degrades. Third point is synchronization overhead. Traditional threads require explicit synchronization mechanisms such as logs, semaphores, and monitors while we share the resources. And potentially, this leads to issues like deadlock and contention. Fourth point is blocking I/O. So traditional threads are often blocked while waiting for I/O operations to be completed. During this blocking period, the thread remains idle, means performing no work, waiting or blocked. So now we can discuss the key points regarding virtual threads. So virtual threads are managed by JVM because there's no intervention is required for each thread execution from operating system. And second point is these are lightweighted. So virtual threads consumes fewer resources and making them suitable for highly concurrent applications. They do not require a system call for each and every thread execution, so making them lightweighted. Third point is scalability. So virtual thread offer advantages in terms of scalability and resource utilizations. And we should carefully evaluate performance implications, especially in latency sensitive or real time applications. And the fourth point is context switching. So, context switching for virtual threads are managed at the application level, and we have more control over thread creations, scheduling, and synchronization. So context switching overhead can be minimized and further performance is also improved, especially in the scenarios those requires frequent I/O operations. And other point is non-blocking I/O. So virtual threads can be designed to perform non-blocking operations. Since virtual threads are lightweighted and managed by application, so they give control back to the runtime system while wait for I/O operation, and other virtual thread can continue its execution. So this approach improves overall concurrency and resource utilization. Yeah, so now we will check the performance of both kind of approach via examples. So I have taken two examples for both kind of mechanisms. So first one is traditional thread. So here I have taken a 50,000 thread count and just printing the name of the threads, and we will see the time elapsed for this process, and I will run this program. Yeah, so here time taken is 8142 milliseconds. That means around 8.1 second. Now I will run Java virtual thread example. Here I have taken thread count as 1 lakh, that is double the count we have taken here. But here we will see what is the performance improvement as compared to this one. So I will quickly run this one. Yeah, so it took only 2.9 seconds. as compared to 8.1 in the traditional thread. So yeah, we can see your virtual thread is more performance efficient and we can use in our applications. Thank you.